Through every problem on this, and I will put some. I will put some formulas on there. So when we get to the other test, if there are certain formulas I didn't give you, but I asked you to memorize them at the beginning of the year. For instance, like I'm thinking midpoint formula, distance formula, maybe slope, how to find the slope, different things like that. I'm going to give you another sheet of paper with all that on there. Okay, so I just want you to learn how to do these things, okay? The memorization, it would be nice if you memorize these things, but I will give you these formulas. Same thing with 1 through 4 on this test right here. All these unit conversions, I will give them to you, okay? So you don't have to memorize every single one of these. Yes? No, there's no multiple choice. It's just like you're taking a regular test. There's 40 questions on the midterm instead of 20. A normal test is 20. The midterm, they give you an hour and a half to do it, so there's 40 questions. And it's going to look just like the problems from the test. Some of the problems might be exactly what was on your old test and the stuff that we're reviewing this week. Some problems might not be exactly, but they'll be really, really close. Okay, instead of 3x plus 5, it might be 2x minus 7 or something like that. Okay, so but it'll look very, very close. So we're concentrating on the test that we've taken, and that's what's going to be on the midterm. All right, so let's do these problems right here. Number 1. It's a unit conversion. It says 21 feet equals blank number of yards. So what we need to do, now a lot of you could probably just look at this and tell what it is. All right, but I want to go through the process. What I'm concerned about is the process, how you get from this to the answer, not just the answer. Because not every single time will you just be able to look at it and just in your head figure out what the answer is. So I want you to know the process, even for these that are a little bit easier. So we're going from feet to yards. So look in your little chart right there on that test. Is there a conversion from feet to yards? 1 yard equals what? 3 feet. Right, that's right on your chart. Now that's something that you should have memorized at this point in your life. This should be memorized, but I'm not going to make you memorize it. It will be on a chart, okay? If you need it in these problems, I'll put it on the chart for you, just like I did on the first test. So let's go through this. What I'm going to do first is this. I always like to put this over 1 because we're going to multiply it by a thing called a unit conversion, okay, or unit multiplier, I should say. So if you remember this goes way back, but if you remember, we have feet on the top, so I want to multiply it by a fraction, so I want to cancel out the feet. So what am I going to put down here? I'm going to put feet on the bottom. Let's do the units first, and then we'll worry about the numbers. So the feet will cancel out. Now what am I changing it to? I'm going from feet to what? To yards. So whatever I'm changing it to, I'll put on the top. All right? So now we've got our conversion right because the feet will cancel out. I'll be left with yards. Now I got to figure out what number goes where. Yeah, 1 goes with the yard and 3 goes with the feet, right? So the 1 goes on top and the 3 with the feet go on the bottom. And let's cancel out. The feet cancel out. And what are you going to do? What do you do with this 21 and this 3? You divide it. So it's 21 divided by 3, which is 7. And then it's in yards, so we put 7 yards. That's all there is to it. Again, a lot of you guys could have looked at this and just said 21 feet. Oh yeah, divided by 3 it's 7 yards. No big deal. But it's the process. It's this thing right here is what I'm concerned about because you're not always going to be able to just do it in your head like you can here. Sometimes the numbers will be a little bit more difficult, right? Because most of you guys understand feet and yards, but then you start getting to pints and cups and ounces and things like that. It's not, it's not as normal for you to see that kind of thing. So the process is what I'm concerned about right here. Number 2, let's do this one. You've got 180 grams. You should be writing this down. Everybody should be writing this down. Everybody should be writing this down. All right, so let's take a look at this one. So 180 grams, you're changing into kilograms. If you look in the book, or not the book, but the little chart that I gave you on this, there is a conversion. It goes from kilograms to grams. It says 1 kilogram equals 1,000 grams. Again, this should be something that you have memorized. You should know the prefix kilo means 1,000. So it takes 1,000 of these 1 grams to make 1 kilogram. That should be something that you already know. But if you don't, I'm giving it to you anyway. So let's go through this process again, just like we talked about before. I always like to put that over 1, and then I multiply it. I got a G on the top or grams on the top. Grams are going to go on the bottom. I'm going to change it to kilograms, so what I'm changing it to always goes on top. Now you got to look at this and decide what goes where. Well, 1 goes with kilograms, and 1,000 goes with grams. Okay? Now look what happens. The grams cancel out, so we have 180 divided by 1,000. Now you can use a calculator if you wanted to. You should be able to do this without a calculator. Watch, if you divide by 1,000 or any power of 10, if you divide, all you'd have to do is move a decimal. Your decimal originally starts right here. If I'm dividing by 1,000, how many places am I going to have to move my decimal? 3 places. 1, 2, 3. So it goes right here. So it starts there and it ends up there when I divide it by 1,000. So it's 0.18. If you want to put the 0 on the end, you can. It's fine. But it's 0.18 what? Kilograms. Now we started off with grams and we're changing it to kilograms. Alright, so it has to be in kilograms. And that's all there is to it. We're going to do 2 more. They're almost just like this. Number 3 is 35 yards, and you're changing that to meters. Now this is probably something that you could not do in your head. You might have been able to do number 2 in your head. You definitely could have done number 1 in your head, but this one I really, really doubt you could just do this in your head. And you want to change it to meters. Just an M by itself is meters. It's not miles. If it was miles, I would probably put an MI, or I'd write out the whole word miles. Okay? But just an M means meters. So I have to change from yards to meters. And we actually have a unit multiplier that changes from yards to meters. So if you look at it, where does it say? It says 1 yard is 0.9 meters. Is that what you said? So 1 yard equals 0.9 meters. Now this is an approximation, but it's good enough for what we're doing right now. So this is important. Where did I get this? Did I have this memorized? No, I didn't have this memorized. Okay, I had the other ones memorized, to tell you the truth, but I don't have this one memorized. But I can use this because I'm going from yards to meters. I've got yards and I've got meters right here. So let's do this. It's 35 yards, put it over 1, and we have to multiply it by a unit multiplier. If yards is on the top, I put yards on the bottom. I'm changing it to meters, so I put meters on the top. Now you got to figure out what number goes with what. Well, look up here. 1 goes with the yard, so I put 1 with the yard. And then the 0.9 goes with the meters, so I put the 0.9 right here, and that goes with the meters. Now this time I'm not doing division, am I? Nope. I'm doing multiplication. Somebody do that for me. Somebody have a calculator out real quick. 35 times... Actually, I have one. I'll just use mine. 35 times 0.9. 35 times 0.9, and that's 31.5. So it's 31.5. Look what happened. The yards canceled out. What was I left with? With meters. Thanks for paying attention. So it's 31.5 meters. We didn't mention inches one time in this whole problem. All right, and there we go. That's how you do it. Let's do number 4. 5.1 liters. 5.1. Now this book uses a capital L. Usually when I do liters, I would do like a lowercase, like a cursive looking L. But they use a capital L, so we'll stay with what they do. So we want to change that to quarts. Now we're changing from the metric system to the English system. This is definitely something that I don't have memorized or how to do. So we got to look at our little chart. Do we have liters and quarts anywhere on our little chart here? Yeah, 1 quart is 0.9 liters. How about that? So 1 quart equals 0.9 liters. It's right there on the chart. Now we're going to use that to do this. Same type of problem we've done 3 times already. So it's 5.1 liters, put that over 1, times, now liters is on the top, liters is on the bottom. And we're changing it to quarts, so I'm going to put quarts on top. Now you look over here, what number goes with what? 1 goes with the quart, and then the 0.9 goes with the liters. Look what happens. The liters cancel out. What am I doing with that 5.1 and that 0.9? Am I multiplying them together this time? No, I'm dividing them. Up here we multiplied because the 0.9 was on the top. Right here we divide because the 0.9 is on the bottom. All right, make sure you know when to do what. So it's 5.1 divided by this time 0.9. And that gives you, now look at this number, 5.6, and it keeps on going, doesn't it? Now it ends in a 7, but does it really end? Now that 6 keeps repeating. They just rounded it to a 7. We don't have to take it that many times. Let's just take it 2 decimal places or even 1 decimal place, tell you the truth. Because look, this only has 1 decimal. This only has 1 decimal. Let's just put 1 decimal for our answer. So what was that again? It was 5 point... Well, we'll take it to 1 decimal, so it would round to 5.7. Now, if you would have put 5.6 or 5.67 or 5.6 repeating, I'd still give you that, all right? But it's probably better just to round it like this. And there you go. There's 4 of those unit multiplier problems. Now we're going to get into some regular type of algebra. These problems say evaluate. This is plug and chug. Remember me talking about that? And then it says if, and then they tell you what these letters are equal to. They say R is equal to 3, Q is equal to 1, and W is equal to -2. All right, and here's what we're evaluating. Let me scooch this down a little bit. Let's see. 5W on the top and 3R plus Q on the bottom. Alright, so this is what we're going to do. We're going to plug and chug is what this is. This is evaluate. So this is what R, Q, and W are all equal to. We're going to stick those numbers in for the letters wherever they apply. So look what's going on. I put my fraction thing. It's 5W. What is that 5 and that W doing to each other? They're multiplying. How do I show multiplication in algebra? I use what? Parentheses. That's the best way to do it. Okay, there's other ways. You could put a little dot, right? They show you how to do the dot. You could put the X for multiply, but I wouldn't do any of that. I would use parentheses. Almost always in algebra, we use parentheses for multiplication. All right, so 5 times W, which is -2. Then on the bottom, look at this. This 3R. That's 3 times whatever R is. And I put the R in parentheses, so it's 3 times 3. Plus a Q. Now the Q is not being multiplied by anything, so I don't really need it in parentheses. So if you look at the Q, it's a 1, so I just put a 1 right there. So that's the plug-in, right? Plug and chug. So that's plugging everything in. Okay, substituting is technically what it's called. We're going to substitute these numbers for those particular letters. Now we work this thing out. I would work out the top first, then the bottom. So let's do the top. It's 5 times -2. Everybody can do that. It's -10. Now on the bottom, you got to do something first. So there's an order that you have to do things in. We call that the order of operations. Do you remember that? So we have to do this first. We got to do the multiplication first. Remember, please excuse my dear Aunt Sally. M is multiplication. You do that before A, which is addition. So we have to multiply first before we add anything to it. So 3 times 3 is what? 9. So then we're going to go 9 plus 1, which is 10. I tell you, I've seen many people, even after I've taught this, that they'll go 3 plus 1 is 4 and then multiply it by 3. Okay, that's not the same answer. Okay, you got to do the multiplication first and then you do the addition. Now don't leave it like this because I want you to simplify your answer. That's not simplified right there. What does that simplify to be? It's just a -1, just as simple as that. All right, so don't leave it -10 over 10. You need to simplify it. Now some people put -10 over 1. I guess that would be okay. I'm sorry, not -10 over 1. Like -1 over 1. Do you really need to write it like that? No, write it nice and clean and simplified. It'd be -1. This is the answer I'm looking for right here. All right? Let's do another one that's kind of like this. But they throw something else. We're still using these same letters, okay? We're still using R, Q, and W, but we're doing this to another problem. It's 8 plus, and then you got this straight up and down bar. Right, it's called absolute value. Everybody see that? Do you remember about absolute value? Yeah, it's the distance it is from 0, or you work whatever's in here, and then your answer is always going to be what kind of a number? It's always going to be positive, that's right. All right, so, oops, let's not scoot it down because I want to still see these letters. Well, there's only one letter I got to plug it into, isn't there? So it's going to be 8 plus. Now watch, don't be too quick to get rid of the absolute value. Let's figure out what it is inside of there first before we get rid of the absolute value. So it's Q minus 5. What is Q? It's 1 and then minus 5. Keep it in absolute value. Now I can scooch it up. Look what we do here. 8 plus, let's figure out what this is. This kind of acts like a parentheses. So we work what's inside there, but it's inside the absolute value, isn't it? Now that makes a big difference. Okay, the negative 4 being inside the absolute value makes a difference. So it's 8 plus, Calvin, would you say? Just plain old 4, isn't it? Because the absolute value of a number is always the positive version of that number. What if it was 8 plus the absolute value of positive 4? Still a 4, isn't it? Right. It's always positive. So work what's in here first. Okay. Do all this stuff inside the absolute value first. Get one number, and then you can go ahead and apply the absolute value. So 8 plus 4 is 12. We good? All right. I know this is a little bit boring and slow because hopefully it is a little bit because you should know this stuff pretty well, and this shouldn't be brand new to you. But I'm going over it just like you've never seen it before because I want you to understand how to do these problems. Good. All right, let's take a look at this. This problem says to solve. Okay, it's not just plugging and chugging. It's not just simplifying. It's actually finding the value of this variable right here. Finding the value of b. Finding what b is equal to. That means we have to get b by itself. Freddy the Hood, you can't have that on. You got to get b by itself. So you have to get rid of that 3/5. Well, what is that 3/5 doing to that b right there? It's multiplying, okay? So normally if something's being multiplied, what do we do to get rid of it? We divide, okay? But it's a fraction, though. You could divide by a fraction, but that's kind of a pain in the butt because if I divided by a 3/5, then it kind of looks a little ugly. But I got another way to divide a fraction. What is that, John? Well, I don't need to put it over 1. Multiply by the reciprocal. Right, that's the term I want to hear. Multiply by the reciprocal. Everybody see that? Because look what happens. If I multiply by the reciprocal means you just flip the fraction. Look what happens to the 5s. They cancel out. Look what happens to the 3s. They cancel out. Everybody see why we're doing that? So we can cancel the stuff out. That's the whole purpose. Now, if I do that to one side, talk to me. I got to do what? I got to do that to the other side as well, don't I? We're going to put that over 1. So watch what happens. I just said it. I'll show it now. 5s cancel out. 3s cancel out. What am I left with now after that all cancels out? I'm left with b. So that's b. So we got b by itself. That was the whole key to this problem. Look at this right here. Now we just have to simplify this. First of all, I always look to see if anything cancels out. Does anything cancel out? Does 3 go into 5? Does 3 go into 2? No. So all we can do is do what? Multiply the top and then multiply the bottom. So negative 2 times 5 is negative 10. 1 times 3 is 3. And that's it. You're done. Just write it like that. Don't change it to a decimal. Don't change it to a mixed number. Just keep it negative 10 over 3. All right? There's no reason to take that any further. That's already simplified. It's already reduced. You can't simplify it anymore. Changing it to a mixed number is not really simplifying the fraction. And a lot of people think that's true. Elementary teachers teach that all the time. It's not really simplifying this fraction. Right? Simplifying means reducing it to its lowest terms. It's already reduced to its lowest terms. We good? All right, so that's one solving problem. And you've probably had to do that once or twice, probably even more than that, in our just regular geometry stuff, right? When we had to solve for x and find missing angles and sides and that kind of thing. This next problem, you've definitely seen quite a bit in our geometry. You've seen stuff like this quite a bit, and you've done a lot of algebra like this. And this is the reason, this is the big reason why I did this chapter 0 in the first place. Because I want you to have a good foundation, because I knew you were doing this stuff later on in the geometry class. So especially for this problem right here. This is a huge problem. It's not difficult, but it's a very important problem because you see math like this all the time now, don't you? When you have to get things equal, you know, you set sides equal to each other, you set angles equal to each other, or you add things up and set them equal to 180 or 90 or stuff like that. This is a problem that you had to learn how to do because we do it a lot in this geometry class. So let's take a look. This right here just had one variable. You just had to get that one thing by itself. But look at this. This has a variable here and a variable on the other side. One on the left side and one on the right side. I don't want them on both sides. Where do I want them? On one side, right? I want them together, right? I want them together on one side. Does it really matter if I put it on the left side or the right side? Doesn't make any difference, okay? Some people just always put on the left-hand side no matter what. If I was going to do this problem, though, what do you think? Yeah, I might add the 6D, just not so it's even, but it's positive, right? Yep. It's funny because somebody in the last class said to make it even, and I know exactly what you meant, but that's what I'm going to do. I'm going to put a plus 6D here and a plus 6D here. That way, look what I get. I get a positive 10D. If I would have subtracted a 4D from this, you could have done that as well, but what would you be left with then? A negative 10D. Would you rather deal with a positive 10D or a negative 10D? If it was me, I'd rather deal with a positive 10D. All right, so that thing's going to cancel out. Now I got the D on the right-hand side. Let's get the 7 on the other side. So how do I get rid of this positive 7? I subtract a 7 because this is being added, so I subtract it. I always do the opposite. Right? Should be very familiar because we do math like this all the time now, right? It's not like we just saw it back then and never saw it again. We see this every single lesson, it seems like, that we do. All right, so that canceled out. And what are you left with? Well, we got a 10D over here on the right-hand side, right? When I add those up, 27 minus 7 is a 20. And now it's really simple after you do this. Divide both sides by 10. And then D is, we don't leave it like this. What does this simplify to be? Just a 2. Plain old positive 2. That's all there is to it. Hope you guys are writing this down. I got 1, 2, 3 with their heads right down on the desk, and they're not writing anything. That still didn't make, still didn't bother you, did it? Does SLD, what if I said SLD? Does that bother you? Apparently not. Apparently not. See, if there's one thing you're going to remember about my class. All right, this problem says graph and label. All right, graph and label. It asks you to do two things. So the labeling is just as important as graphing this thing. And here's what they give you. They give you a point. They call it point R, and it's the point -2, -4. All right. So we're going to graph it. Now on the test, on the answer sheet on the test, I'll give you a little graph. Okay. But it's going to be up to you to put it in the right spot and to label it. So I'll give you a graph, and they'll, those lines will go all the way through, just like graph paper. But I'll just mark them right here for now, so you won't have to go through all that stuff. All you got to do is put the point where it's supposed to go and label it. Right? It says graph and what? Label. Okay. So it's -2, -4. This is the x-axis. This is the y-axis. So which direction do we go first?
Negative.
We go in the x direction, right? And you do go to the left. All right. So you start here, and I'll tell you what. Let's do this in purple since that's our color. So we start here at the origin, and you go 2 to the left. 1, 2. Now we don't stop right there, though, do we? Then we go 4 what? Down. 1, 2, 3, 4 would be right here, and we put a point. Are we finished? Is that it? Do I go on to the next problem? No, I've graphed it, but now I have to do what? Label it. So that's point R. Now you could, if you want to, you could label it like that. Probably the best way is just to go ahead right next to that point. Label it like that. Okay? So you're telling me exactly where that point is. It's -2, -4. There's the name of it, point R, and there's the label of it, -2, -4. Everybody good? Take that as a yes. I'll take silence as a yes. All right, let's do one more, and we'll be finished. How about that? That was quick. Let's do this. Let's get another graph, and I'll label it 1, 2, 3, 4. But this time we're not just labeling a point. What does it say? It's a triangle. That's right. We need to graph a triangle. All right, so that means they're going to give you, how many points are they going to give you if they give you 3? Right, because 3 points will make a triangle. And L is -1, 2. Okay, so here we go. Let's label. So this is basically the last problem, but 3 times, isn't it? That's basically all it is. So it's 1, 4. So you got to go to the right one or 1, -4. Go to the right one and down 4. It'd be right there. Let's label it. So it's J, and we'll even put 1, -4 right here. Oops, sorry. All right, let's do the next one. Let's do K. It's 2, 3. So we go to the right 2 and we go up 3. Label that 2, 3, and it's point K. And then the last one is negative 1, 2. You go to the left 1, you go up 2. It's point L, and that's negative 1, 2. All right, there I go. So I put all 3 points in there. I'm done. Can go on, right? I'm finished? No. What do I have to do? I got to connect the dots. That's right, because it says graph the what? Graph the triangle. So it needs to be a triangle. It just can't be 3 points just sitting out here in the middle of nowhere. All right? It's 3 points, and if I connect them together, that makes the triangle. So I have to see the triangle because it says graph the triangle, and it says, well, it doesn't say label it on this, but I do want you to label it. Okay? And I've labeled it. I've labeled all 3 letters, and I've labeled where those vertices, where those points to that triangle are located. All right? Does that make sense? All right, good. Well, that's it. So tomorrow, we'll probably won't start, we'll do chapter 1, but we probably won't start at number 1 through 10, okay, because I'll probably do that in the 3rd period class. We'll probably start around number 11 or so tomorrow. But it's going to be up to you. You're still responsible to know 1 through 10. And you're supposed to go to YouTube, watch the video, and learn how to do it. Okay? Any questions on this?